Hey guys, welcome to my channel. When it comes to large-scale engineering, Chinese engineers have long been renowned for their impressive construction speed and astonishing projects, such as the Pingtang Bridge and Beipanjiang Bridge among others. We'll delve into these in detail in the upcoming video. Chinese engineers are like superheroes in the field of construction, actively contributing to their nation's infrastructure needs, keeping up with the ever-growing population and rapidly advancing economy and technology. China has been at the center of the world's economic rise for the past few decades. With rapid economic and technological development, China's demand for infrastructure construction has continued to rise. This has earned China the reputation of being an infrastructure maniac on the international stage. This nickname is not meant pejoratively but reflects the awe and admiration of the American people for China's infrastructure development. We all know that since the 1990s, China has built some awe-inspiring skyscrapers, massive cities, and fast transportation networks. However, one lesser-discussed aspect of China's rise is the construction of giant bridges, which is one of the country's most outstanding achievements in infrastructure. As of today, China boasts more than 1 million bridges, some of which break through geographical and technical barriers, providing unprecedented connectivity between different regions in this vast country. In this video, we'll explore China's large bridge projects and share the fascinating stories behind them. But before we proceed to show you these projects, we earnestly request you to subscribe and enable notifications so you won't miss our exciting updates. We value your thoughts, and we invite you to share your views on these remarkable engineering achievements in the comments below. Bridges are marvels of human engineering, connecting different places, reducing travel time, and improving traffic efficiency. However, some bridges are awe-inspiring and frightening at the same time, hanging high above chasms or spanning turbulent seas. In this video, we'll take you to some of the most hair-raising bridges in China, uncovering their stories and secrets. Are you ready? Let's get started. First, we head to the Longjiang Suspension Bridge in Yunnan, China. This bridge connects the cities of Baoshan and Tengchong and stands at a height of 300 meters, equivalent to the height of a 100-story building. The bridge is located in a seismic zone with a history of strong earthquakes. To ensure the bridge's safety, engineers employed advanced seismic technologies and materials. But you can imagine the feeling of experiencing an earthquake on a bridge 300 meters high. It's bound to be hair-raising. Yet, that's just the beginning. We'll soon see even higher and more dangerous bridges. The Siju Bridge spans the Sida River, linking Inshi-Tujia and Miao Autonomous Prefecture in Hubei Province with Fingjie County in Chongqing City, serving as a vital connection between China's central and western regions. It stretches approximately 2.5 kilometers and soars to a height of 560 meters, surpassing the Empire State Building in height. Constructing this bridge posed an immense challenge due to its location nestled between two towering mountains, spanning a deep and precipitous valley. Engineers even used rockets to launch the first cable across. After 3 years of grueling efforts, this bridge was finally completed. Driving on this bridge allows you to enjoy magnificent landscapes in a thrilling experience. But this is not the world's highest bridge. That title belongs to another Chinese bridge. It is the Beipanjiang Bridge. The bridge has a total length of 1,314.4 meters and is part of the Hangrui Expressway. It starts from Duj Town in Yunnan and reaches Laolong Village in Guizhou. In between, it spans the Nizhu River Grand Canyon, earning it the name Nizhu River Bridge. The completion of the Beipanjiang Bridge marked the full opening of the 3,404-kilometer-long Hamrui Expressway. What sets it apart is its height above the river, standing at a staggering 565.4 meters, equivalent to the height of a 200-story building. In the world of bridges, it is considered the tallest. If a person were to fall from the bridge, it would take over 10 seconds to reach the ground, a terrifying prospect for anyone. Beipanjiang Bridge claimed the top spot in the world's highest bridge competition, setting a Guinness World Record in 2018. However, China didn't undertake the construction of this bridge for awards. It was done to facilitate local travel. The distance between Duge Town and Puli Township may be relatively short, but the challenging, mountainous terrain and absence of a direct road turn it into a 4-hour journey, requiring travelers to traverse 3 mountain ridges and cover around 40 kilometers of mountain roads. However, with the completion of the bridge, the journey was reduced to just 1 or 2 minutes, greatly enhancing the convenience of travel between the two sides and promoting economic development in the region. Why was the bridge constructed at such a high relative altitude of 565.4 meters? The area where Beipanjiang Bridge is located, within the Yunggui Plateau, features a karst landscape formed by the dissolution and deposition of soluble rock by underground and surface water. The fragile mountain structure in this region doesn't lend itself well to bridge construction. After a year of surveying and exploration, Chinese engineers determined that 565.4 meters was the optimal height to avoid caves and fissures. When planning the Beipanjiang Bridge, American engineers claimed that it would take China 3,000 years to complete. However, the bridge's construction began in 2013, and it was operational by the end of 2016, taking only 4 years. The bridge is made up of a pair of massive concrete towers. The tallest is 269 meters high. The 20,000-ton steel bridge deck is the length of 5 Titanic. One World Trade Center in New York could fit underneath. The deck is attached to the towers with 400 kilometers of cables, enough to stretch from London to Amsterdam. The Beipanjiang Bridge stretches 1.3 kilometers across the ravine. The tips of the towers reach 750 meters above the valley floor, higher than 2 Eiffel Towers and the Statue of Liberty combined. During the construction of the Beipanjiang Bridge, Chinese engineers encountered numerous incredible difficulties and challenges. The first was the terrain, as the Beipanjiang Canyon had steep terrain and complex geology, making construction extremely difficult. The second challenge was extreme weather. Constructing a bridge in the southwestern region entailed addressing recurrent geological hazards, in addition to contending with severe weather conditions such as strong winds, dense fog, heavy rain, and freezing temperatures, which placed high demands on the bridge's ability to withstand these conditions. The primary question was what type of bridge to construct. Conventional beam bridges, arch bridges, and concrete cable-stayed bridges couldn't span the 670 meters of the Beipanjiang Canyon. Designers had to choose between steel truss bridges, cable-stayed bridges, and steel truss girder suspension bridges. Due to the fragile cliff slopes of the karst region, which couldn't support the load of a suspension bridge, a cable-stayed bridge was ultimately chosen. To manage economic costs and environmental impacts, Chinese engineers designed the Beipanjiang Bridge as a double-tower cable-stayed bridge with a span of 720 meters. After the promising blueprint was created, the real challenges began. The U-shaped Nizhu River Canyon extended over 500 meters deep, making it impossible to transport the bridge sections, each weighing hundreds of tons, to the construction site. As a solution, designers divided each section into smaller units of around 10 tons and used reassembling and cantilever launching techniques. Furthermore, Chinese engineers had to use 224 strands of 15.2 millimeter diameter cables to support the weight of the entire bridge, a seemingly impossible task that was achieved with galvanized steel wire boasting a tensile strength of up to 1770 megapascals. To counteract corrosion of the cable stays from extreme weather, Chinese engineers added layers of galvanization, grease, and HDPE both inside and outside the stays, significantly extending their lifespan. On September 10, 2016, after overcoming numerous challenges, the Beipanjiang Bridge was officially completed. Would you dare to drive on this bridge? If you find this terrifying, stay tuned for even more spine-chilling bridges to come. The Jinshajiang Bridge, which crosses the Jinsha River in Yunnan. The main tower is 228 meters tall, with a vertical height of 479 meters, which is equivalent to the height of a 170-story building. The height from the bridge deck to the valley bottom is 335 meters, making it the second highest bridge in the world, surpassed only by the Beipan River Bridge. The Jinsha River Bridge is currently the world's largest cable-stayed bridge spanning a mountainous gorge, with a length of 1,386 meters, consisting of 128 steel truss segments. Each individual steel truss segment weighs a staggering 175 tons, which is equivalent to the weight of over 100 family cars. The bridge's two main cables are composed of 42,000 high-strength galvanized steel wires, with a total length of 87,000 kilometers, enough to encircle the Earth twice. When it comes to the world of bridges, China's achievements are not just bragging. China's bridge construction technology is truly incredible. Next, we visit the Liujiang Bridge, a giant bridge that stretches 798 meters across a treacherous mountain valley. While its length may not compare to some of the other super bridges in this video, the Liuji River Bridge is considered an engineering marvel. It holds the record as the world's longest single-tower suspension bridge, distinguishing itself from bridges of similar length with its sole tower, while the remaining structure is supported by cables from a distance. This bridge appears as if it's defying gravity, hanging in midair without visible support. Furthermore, this bridge was constructed in challenging terrain, extending from a 156-meter-tall tower to an anchor point at the far end of a tunnel, all on a steep slope with a 54-degree incline, setting the world record for the steepest tunnel anchor point. Despite its complexity, this bridge plays a crucial role in remote areas, becoming a key component of the 190-kilometer-long U2 expressway that connects Yunnan to major centers like Shanghai. Previously, navigating this valley took over an hour, but the Liujiang Bridge reduced that time to just 2 minutes, allowing vehicles to travel at speeds of up to 80 kilometers per hour on the 4-lane bridge. This complex megaproject started in 2019 and was completed in 3 years. This bridge has significantly improved the underdeveloped infrastructure in the mountainous regions of China, promoting economic and transportation connections in the surrounding areas. It has played a crucial role in advancing tourism and economic development in the central Yunnan region. Next, we arrive at the Hong Kong-Zhuhai-Macau Bridge, located between the Chinese provinces of Guangdong and Hong Kong and crossing the South China Sea. It holds the record as the world's longest sea-crossing bridge, stretching 55 kilometers and curving like a dragon above the sea. This bridge not only connects the major cities of Hong Kong, Zhuhai, and Macau, but also promotes economic and cultural exchanges. However, its construction has been fraught with controversy and risks. During construction, nearly 20 workers lost their lives, and there was a scandal involving falsification of concrete quality. Additionally, American engineers questioned whether this bridge could withstand the impact of strong winds and huge waves. Although these allegations were officially denied, the safety of this bridge remains a subject of debate. Our journey is not over yet. We're about to show you a bridge that is nothing short of breathtaking. The Qishui River Bridge, another super bridge constrained by extreme geographical conditions, spans over 2,000 meters, connecting the provinces of Sichuan and Guizhou, with a peak height of approximately 350 meters. Constructing this bridge posed a major challenge due to the limited access to the construction site on the Sichuan side, where cliffs made it impractical for most heavy equipment traditionally employed in bridge construction to reach the area. Thus, engineers decided to build the bridge deck off-site and later transport it in 3 segments to the gorge. They used 158 cables to support the bridge deck, ensuring its proper placement using 3D visualization technology. The construction budget for this bridge was just $147 million, far lower than some of the astonishing super bridges we'll mention shortly. Then there's the Bailing River Bridge, a cable-stayed steel box girder bridge located above the Bailing River in Guizhou. Completed in 2017, it spans 1,080 meters with a vertical height from the bridge deck to the valley floor of 370 meters, equivalent to 120 stories, making it the world's 8th highest bridge. Next, we visit the Guozhou Bridge in Xinjiang, which is Xinjiang's first cable-stayed and highest bridge. It is the largest and most important bridge in Xinjiang, as well as China's first road steel truss cable-stayed bridge, considered a miracle of infrastructure construction in Xinjiang. The Guozhou Bridge spans approximately 700 meters, with the bridge deck height above the valley floor of about 200 meters. The entire main bridge is constructed using steel truss technology, with 17,000 tons of specialized bridge steel and high-strength bolt connections instead of traditional welding. Precision during installation had to be maintained within 2 millimeters, costing about $3.4 million per meter, with a total cost of $2.39 billion. In constructing the Guozhou Bridge, groundbreaking technologies were applied, such as large-volume concrete temperature control, tower and beam asynchronous construction processes, hydraulic jacking, and self-moving templates, establishing valuable experience in constructing highways in mountainous areas. The Guozhou Bridge boasts a spectacular and unique design. Its S-shaped structure winds through the valley, surrounded by towering peaks and colorful flowers. Driving across this bridge feels like being in a painting. Finally, we arrive at the Aizhai Bridge, a cable-stayed steel box girder bridge located above the Aizhai River in Hunan. Completed in 2016, it stretches 1,176 meters with a vertical height from the bridge deck to the valley floor of 336 meters, ranking it as the world's 9th highest bridge, following the Beipanjiang Bridge, the Jinshajiang Bridge, and the Balu River Bridge. The long dragon-like main span resembles a great sword piercing the clouds, and it appears as a rainbow bridge, connecting the picturesque landscapes on both sides of the valley. The two towering 206-meter-tall main towers serve as the guardians of the bridge, especially dazzling at night. The cable length and height of the bridge deck above the ground also reach the world's peak. These accomplishments showcase the unwavering spirit of Chinese engineers and their relentless pursuit of the unknown. The Aizhai Bridge goes beyond human imagination, incorporating elements of harmony between people and nature, tradition and modernity. It embodies the courage of Chinese engineers in innovation and conveys respect for nature. It will undoubtedly become a lasting human miracle, inspiring future generations to stay true to their original aspirations and promote a positive cycle of harmonious development with nature. Standing on the observation deck at 200 meters high, you can not only witness the magnificent landscapes but also contemplate the harmonious coexistence of humans and nature. These are the most hair-raising bridges in China that we've shared with you. China's bridge projects are undeniably magnificent spectacles, transforming not only the country's domestic transportation and economic landscape but also showcasing China's extraordinary strength in bridge construction technology and innovation. These bridges are not just transportation facilities. They symbolize the relentless pursuit and innovation of the Chinese people, symbolizing the unyielding spirit of exploration in the face of challenging projects. China's bridge construction not only brings invaluable experience domestically but also inspires other countries to actively catch up with China's leading position in infrastructure development. Chinese engineers continue to break technological barriers by building enormous transportation bridges. These bridges are crucial elements of China's vast road network, enabling efficient and rapid transportation. It's worth mentioning that many of the world's most challenging and record-breaking bridges were designed and constructed by Chinese engineers. China's commitment to infrastructure development has created a miracle that impacts the lives of over 1 billion Chinese citizens and drives domestic economic growth. These cases demonstrate the remarkable achievements China has made in bridge construction in recent years, garnering worldwide attention and setting a positive example for other countries. The extraordinary capabilities of China in bridge construction have convinced many Americans that China is a developed country. What are your thoughts on China's astounding capabilities in bridge construction? Which bridge left the deepest impression on you? While China every day is making amazing progress, achieving real results for technology, infrastructure, improving the nation building and working hard to improve the standard of living for the people, China next door neighbor India on the west border is always busy with their ton of boastful hypes, self-praise on their leadership, chanting superpower, dreaming of replacing China as world manufacturing country, but with not much real achievement, progress, and result. For instance, India plans to construct a railway bridge taller than the Eiffel Tower, named the Chenab Railway Bridge, located in the Jammu and Kashmir region. The bridge is designed with a lifespan of 120 years and a height of 359 meters, surpassing the Eiffel Tower by 35 meters. Construction on this bridge began as early as 2002, with the original completion target set for 2009. However, it was abruptly halted in 2008. The project remained at a standstill. In 2010, construction resumed, with Indian media claiming it would be finished by 2016. However, reality proved astonishing. By 2016, only the Bach Bridge pier of the Chenab Railway Bridge had been completed. Full construction resumed in 2017, and due to various reasons, the planned completion was further delayed to 2019. This series of setbacks has led to a prolonged delay in the completion of the Chenab Railway Bridge. The primary reasons include India's weak overall capacity, coupled with the high cost of construction materials, exacerbating India's already challenging economic situation. Furthermore, India lacked experience and technical expertise in the construction process, resulting in frequent issues and a decline in construction speed. Ultimately, the Grand Bridge took 21 years to complete, and it is expected to be operational by 2024. In summary, although India's Chenab Bridge incorporates high-tech materials and advanced construction techniques, surpassing China's infrastructure prowess remains a formidable challenge. In comparison, China's construction of the Three Gorges Dam, a hydraulic project, has attracted widespread attention and is hailed as an unparalleled feat in hydraulic engineering. Besides, they still have the gut and not ashamed to belittle and criticizing China infrastructures are built like tofu. China's success must have made them very upset, jealous and frustrating that many of their media channels know a day we don't see negative news, fake news and propaganda reports bashing and mocking China like a dog barking at the neighbor daily. But the China just ignored the dog barking noises and keep moving forward to get their business done to achieve what they aim for. Without further ado, let's get straight to the point. Firstly, let's take a look at the super bridge built in China at a cost of nearly $800 million, the Yachi Bridge. This grand bridge stands atop a cliff at an impressive elevation of 434 meters, with a total length of 1,200 meters. So, what was the level of difficulty in constructing this bridge? With a magnificent main span of 436 meters and a total length of 971 meters, the Yachi Bridge is not only the world's largest continuous rigid frame bridge with a steel-concrete composite deck and a cable-stayed basket handle arch, but also the longest span high-speed railway bridge of its kind. The construction of the main tower's reinforcing steel used a groundbreaking method where steel was bound and formed into shape on the ground before being lifted and installed on the tower columns. The hydraulic climbing formwork employed a system with fewer pole rods, enhancing the appearance and quality of the tower column's concrete. The connection of the bridge's steel truss arches involved precision welding and bolting, demanding extremely high machining and assembly accuracy, controlled to within millimeters. Any deviation exceeding 2 millimeters could result in misalignment of the bolted joints. The entire bridge required approximately 130,000 cubic meters of concrete, and the steel used in the truss beams amounted to over 16,000 tons. In the gorge where the bridge is situated, instantaneous wind speeds can reach up to force 10. The cable tower's top is 110 floors above the Yachi River surface, posing extremely high construction safety risks. American engineers boldly claimed that China couldn't complete such a project due to its complexity. However, Chinese engineers overcame numerous challenges, successfully completing the Yachi Bridge, showcasing the dominance of Chinese bridge construction technology and marking a significant milestone in the development of the Chengdu-Guiyang high-speed railway. Let's continue to explore one of the ongoing epic engineering projects in China, the Pingla Grand Canal. The canal starts at the mouth of the Shajing River in the West Jinsi Reservoir, spanning approximately 135 kilometers in total length. The overall route of the project is divided into 4 sections: Shaping River Section, Watershed Ridge Section, Qinzhou Mainstream Section, and Estuary Section. Among these, the Watershed Ridge section requires manual excavation, connecting to the Qinzhou mainstream through Luwu Town in Lingshan County, Qinzhou. The waterway is constructed to a first-class standard for inland water navigation, allowing for the passage of 5,000-ton inland vessels. The Grand Canal eventually flows into the Bibu Gulf through the Shajing estuary. Upon completion, this project will significantly shorten the maritime route for goods from the southwest region of China by over 560 kilometers compared to exiting through Guangzhou. This new canal, resembling a soaring dragon, is a crucial component of the West Land Sea New Channel and marks the first inland canal since the establishment of the People's Republic of China. To construct this supersized canal, the Chinese government has invested a staggering 72.7 billion yuan. In the process, Chinese engineers are tasked with excavating approximately 329 million cubic meters of earth and rock, a quantity 3 times that of the Three Gorges project. The excavated materials will be utilized for purposes such as land reclamation, ecological restoration, and infrastructure development, contributing to China's sustainable development. The Pingla Grand Canal can be described as a monumental canal construction project. On the construction site, vehicles rumble back and forth with the deafening roar of machinery, showcasing the significant importance China places on this canal's construction. With a total length of about 140 kilometers, the Pingla Grand Canal can accommodate vessels of up to 5,000 tons. Once completed, the canal will not only facilitate navigation but also serve functions such as water supply, irrigation, flood prevention, and improvement of the water's ecological environment. Throughout history, the Chinese people have never shied away from challenges. Millennia ago, in an era with underdeveloped construction technology, China built the Great Wall, a wonder of the world. In modern times, despite being besieged by Western powers, China successfully constructed the Jingjiang Railway and the Qiantang River Bridge. These remarkable feats remind us that if miracles had a color, it would undoubtedly be Chinese red. It is understood that the Pingla Grand Canal is expected to be completed and navigable by the year 2027. By then, we will witness firsthand this magnificent new marvel in the history of Chinese infrastructure development. Next, we arrived at the construction site of the Huajiang Canyon Bridge. This bridge spans the Huajiang Grand Canyon, famously known as the world's Great Rift. The bridge piers are strategically positioned at both ends of the mountain range, and the central section of the bridge is entirely suspended in midair. It is a single-span steel truss cable-stayed bridge. The Huajiang Grand Canyon stretches approximately 80 kilometers, making it the longest canyon in China. Within the canyon, towering peaks and deep river valleys create a nearly 1 kilometer relative height difference, earning it the title of the Earth's crevice. Constructing a bridge in such challenging terrain comes with numerous difficulties. The highest tower of the bridge, the design tower, reaches a height of 262 meters, equivalent to the height of more than 80 floors of a building. With a main bridge span of 1420 meters and a height of 625 meters from the bridge deck to the water surface, This colossal steel truss cable-stayed bridge is set to break world records. Upon completion, the bridge is expected to surpass the Beipanjiang Bridge and become the world's tallest bridge. The bridge is anticipated to be completed in 2025. Xiangxi River Bridge is a pioneering bridge in China with a lute-shaped design. The bridge is a single-tower, single-cable surface inclined tower cable-stayed bridge with a total length of 364 meters, a main span of 238 meters, and a tower height of 126 meters. The bridge tower adopts a lute-shaped design with a 10 degrees inclination along the bridge axis, and the tower body transitions smoothly through the combination of ellipses, circular curves, and straight segments, making it both structurally complex and aesthetically pleasing. The bridge is located in the Three Gorges Reservoir area, where geological conditions are complex, including karst caves and faults, placing it at the forefront of similar bridges in terms of comprehensive construction difficulty in the country. The Hutuo-Ng Yangtze River Bridge represents the highest level of bridge construction in China. It is also the world's first dual-use cable-stayed bridge with a main span exceeding 1 kilometer. The total length of the bridge is 11,072 meters, and the main bridge adopts a double-tower cable-stayed design with a main span of 1,092 meters. Up to now, the project has consumed 480,000 tons of steel, equivalent to 12 birds' nest stadiums, and 2.3 million cubic meters of concrete, equivalent to 8 national grand theaters. The bridge has 432 cable stays with a total weight of 17,747 tons, using 2,000 megapascal high-strength zinc aluminum-coated steel wires for the first time in the world. After completion, the bridge can withstand the impact of a typhoon of intensity 13 and a 100,000-ton class vessel. The immense scale, high standards, and great difficulty of the project represent the highest level of similar bridge construction in China and even the world. This title isn't a criticism, it's a reflection of how foreigners marvel at the rapid pace and cutting-edge technology behind China's megaprojects. As we're all aware, China has undergone unprecedented transformations, particularly in its eagerness to build megaprojects to cater to its ever-growing population. Over the past 3 decades, China's infrastructure landscape has seen a truly astonishing evolution, defying expectations and leaving the global community in awe. Starting from humble beginnings, China's infrastructure journey stands as a testament to its unwavering dedication to progress and innovation. Today, we'll explore some recent megaprojects in China that will absolutely astound you. But before we dive into our discussion, we kindly ask for your support by liking this video and subscribing to Machine Eye. Your thoughts matter to us, and we invite you to share your opinions in the comments below. Without further ado, let's embark on an extraordinary journey. already be familiar with China's reputation for colossal infrastructure endeavors, encompassing not only remarkable buildings and transportation systems, but also groundbreaking technology and energy initiatives. The first mega project we want to introduce is the Chinese International Space Station. This is China's very own space laboratory and the second operational space station in orbit after the Russian Soyuz. The Chinese International Space Station consists of 3 modules with a total mass of approximately 90 tons and a design lifespan of 10 years. It will conduct various scientific research and technological experiments across multiple fields and invite astronauts from around the world to explore the mysteries of space together. Currently, 5 of its components have been launched, and 6 astronauts have conducted long-term stays and work on board. By the end of 2022, it's expected to complete all module launches and dockings and officially begin its operations. This project not only solidifies China as a space superpower, but also enhances our understanding of the universe. Would you like to visit the Chinese International Space Station? I certainly would, but I need to shed some weight first, or I won't make it onto the spaceship. The second mega project we'd like to introduce is the Hong Kong-Zhuhai-Macau Bridge. This is a colossal sea-crossing bridge connecting Hong Kong, Zhuhai, and Macau, stretching over 55 kilometers, equivalent to 13 Manhattan Islands put together. It cost 126.9 billion renminbi to build, which is like buying 1,269 luxury mansions. The bridge employed advanced bridge building techniques, including land reclamation, an ultra-long underwater tunnel, complex tower structures, high-performance steel, and concrete among others. Among them, steel consumption reached an astonishing 420,000 tons, which is equivalent to building 60 Eiffel Towers. From an overall perspective, the Hong Kong-Zhuhai-Macau Bridge is primarily composed of 3 parts: a bridge, a tunnel, and artificial islands. It starts from the Hong Kong port, stretches westward across the Lingdingyang Sea, and connects Zhuhai and Macau. The total length is 55 kilometers, with the sea crossing section covering 42 kilometers, including both sea bridges and underwater tunnels. Artificial islands connect the bridge and tunnel segments in the middle of the sea. How are these artificial islands constructed? The foundation of the artificial islands was formed using 120 steel cylindrical structures, each with a diameter of 22 meters, a height of 39 meters, and a weight of 600 tons. These cylinders were prefabricated on the shore, transported to the sea by ships, and then sunk in the construction area of the artificial islands. The sand was filled inside them, creating a reclaimed land in the middle of the sea, forming the land base of the artificial islands. In simple terms, it's like building a massive retaining wall. Once completed, the area of the artificial islands reached 100,000 square meters, larger than 10 standard football fields. After crossing the sea bridge, vehicles can drive into the underwater tunnel. The underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge is 6.7 kilometers long, making it the longest submerged tube tunnel in the world. How was the underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge constructed? In the 6.7-kilometer underwater tunnel, the deeply buried section is 5,664 meters long and is constructed by connecting 33 sections of reinforced concrete structures known as caissons. These caissons are 180 meters long, 37.95 meters wide, 11.4 meters high, and weigh approximately 80,000 tons, equivalent to the weight of an aircraft carrier. They were sequentially lowered into grooves on the seabed, over 40 meters deep, and then seamlessly connected with an error control of within 2 centimeters. The connected caissons had to ensure they would not leak water for 120 years of use, illustrating the high construction difficulty of this project. During its construction, it faced numerous challenges such as strong winds, tides, earthquakes, navigation protection, and environmental preservation. However, the Chinese didn't give up, and after 10 years of hard work, it was completed in 2018 and was hailed as one of the 7 wonders of the modern world by The Guardian. This bridge not only reduces travel time between the 3 regions, but also promotes economic and cultural exchanges. This project is truly remarkable. turning the three regions into an integrated market and making it more convenient for us to travel and shop. Would you like to visit the Hong Kong-Zhuhai-Macau Bridge? I certainly would, but I need to save up some money first, or I won't be able to afford anything there. The third mega project we'd like to introduce is the Matua Hydropower Station. Located upstream of the Yarlung-Zangbo River in Tibet, it is the second largest hydropower station in the world, only surpassed by the Grand Inga Dam in the Congo River's Inga Falls. The Matua Hydropower Station has an installed capacity of 16 million kilowatts, double that of the Three Gorges Dam, and an annual electricity generation of 74 billion kilowatt hours, equivalent to 10% of the national hydropower output. The construction of this hydropower station will greatly improve energy supply in Tibet and support the national goals of carbon neutrality and peak carbon emissions. Currently, the project has completed its survey phase and is expected to commence construction in 2022, with operations beginning in 2028. This project is truly eco-friendly, transforming Tibet into an energy-rich region and helping us better protect the environment and combat climate change. Would you like to visit the Matua Hydropower Station? I certainly would, but I need to learn some Tibetan, or I won't be able to communicate when I get there. The fourth mega project we'd like to introduce is the Cheongzhou Strait Cross Sea Tunnel. This tunnel will connect the Liezhou Peninsula in Guangdong Province with Hainan Island, making it the third largest strait in China after the Taiwan Strait and the Bohai Strait. The Cheongzhou Strait Cross Sea Tunnel will accommodate both passenger and freight rail lines and will be dug 150 meters below sea level without disrupting maritime traffic. The project was approved and construction began in 2019, with a total planned investment of 150 billion renminbi. Once completed, it will link the high-speed rail networks of Guangdong and Hainan, reducing travel time between the two regions and facilitating the development of Hainan's free trade port. This project is truly marvelous, turning Guangdong and Hainan into a one-hour living circle and allowing us to enjoy the sunshine and beaches more quickly. Would you like to visit the Cheongzhou Strait Cross Sea Tunnel? I certainly would, but I need to buy a high-speed rail ticket, or I won't be able to catch a ride there. The fifth mega project we'd like to introduce is the Hongqi River Project. This is an ecological project that will divert water from the Yarlung-Zangbo River and Nujiang River to turn 30 to 80 million mu of desert into arable land, effectively solving the problem of aridity. This project will transport water from high-altitude areas in Tibet to the dry regions of Xinjiang without the need for electrical pumping. It will be entirely gravity-fed. The project requires significant investment, 10 times that of the Three Gorges Dam, and is a monumental project of our time with long-term benefits. Currently, it's in the planning stage and has not yet officially started. This project is truly magnificent, turning Xinjiang into an oasis and helping us better protect the environment while increasing food and water resources. Welcome step into the world of grand construction projects, where ambition knows no bounds and challenges are embraced with gusto. The global construction industry is experiencing an unprecedented rise, driven by an insatiable appetite for larger-than-life endeavors. First on our list is Crossrail 2, the proposed railway line that will stretch from Surrey to Hertfordshire in the United Kingdom. This ambitious project is set to alleviate London's overcrowded transport network, sparing commuters the agony of packed trains. Imagine bidding farewell to those dreaded 2-hour journeys and reveling in a mere 48 minutes of travel bliss. With construction expected to commence this year and completion slated for 2030, Crossrail 2 promises a faster, more efficient commute for the denizens of London. Next, we venture to India, where the Mumbai International Airport is poised to take flight. This forthcoming aviation hub aims to serve the bustling city of Mumbai, catering to the needs of a staggering 100 million passengers annually. Set to become one of the busiest airports in the world, this colossal undertaking will redefine the concept of air travel in India. So, buckle up, folks, and get ready to embark on a journey that will leave you in awe of Mumbai's soaring ambitions. But let's not forget about Africa, where the grand Ethiopian Renaissance Dam is taking shape. Africa is the land of stunning landscapes, vibrant cultures, and a dam that's making waves, literally. Get ready to be blown away by the grand Ethiopian Renaissance Dam, the hydroelectric behemoth currently taking shape on the majestic Blue Nile River. This dam is set to be the heavyweight champion of the continent, packing a powerful punch with its colossal capacity of 6,000 megawatts. As completion draws near, the excitement is palpable, and not just because we can't wait to see the dam's dazzling light show. The Grand Ethiopian Renaissance Dam is a true symbol of Ethiopia's unwavering commitment to progress and sustainable development. It's like the country's way of saying, "Hey, world, we're harnessing the power of nature to make our mark." Now, let's dive into the nitty-gritty of this engineering marvel. Picture a 1,780-meter long and 155-meter high roller-compacted concrete gravity dam. It's a real heavyweight champ, creating a whopping 1,680 square kilometers of reservoir area. And as if that wasn't enough, there's a 5-kilometer-long, 60-meter-high concrete-faced rock-fill saddle dam in the mix, boasting an embankment volume of approximately 17 million cubic meters. But hold on to your hard hats, because there's more to this dam than meets the eye. It's got its fair share of controversy too, making it the hottest topic in international water cooler discussions. We're talking about a long-standing dispute between Ethiopia, Egypt, and Sudan over the precious waters of the Blue Nile. You see, Ethiopia holds the reins to more than 80% of the Blue Nile's flow within its own borders. That's a whole lot of responsibility and power. Meanwhile, downstream neighbors Egypt and Sudan are feeling a little parched, fearing that the dam's construction might turn their territories into desert wastelands. The drama is real, folks, but so is the grandeur of this project. Construction on this 4 billion-pound dam kicked off in April 2011, and as of the beginning of 2020, it was already 2/3 complete. And if all goes according to plan, this hydroelectric masterpiece will come to life by the end of 2023, ready to electrify the nation and maybe even set the stage for a blockbuster water-sharing agreement. So, keep your eyes on the horizon, because the Grand Ethiopian Renaissance Dam is about to make a splash like no other. It's a testament to human ingenuity, a symbol of Ethiopia's aspirations. Now, prepare to cast your gaze upon the skies of Jeddah, Saudi Arabia, where the Jeddah Tower aims to pierce the heavens. Formerly known as the Kingdom Tower and Mile High Tower, this skyscraper in the making seeks to reach a staggering height of 1,000 meters. Once completed, it will proudly claim the title of the tallest building in Saudi Arabia and the world. However, it seems that dreams sometimes encounter stumbling blocks, as the project is currently on hold. But fear not, for patience is a virtue, and one day we may witness this architectural marvel standing tall against the Arabian skyline. Our next stop is Suzhou, China, where the Suzhou Zhongnan Center is defying gravity with its lofty aspirations. Initially planning to soar to a height of 729 meters, the project had to bow down to China's ban on buildings taller than 500 meters. Nevertheless, at a still impressive 499 meters, this towering structure promises breathtaking views of Jinji Lake and Suzhou's magnificent skyline. So, keep your eyes on the horizon as Suzhou prepares to welcome this architectural behemoth into its midst. From soaring heights, let's descend beneath the River Thames in London, England, where the Thames Tideway Tunnel is carving a path to protect the river for the next century. This new sewer tunnel, with a price tag of £4.2 billion, will ensure that London's waste is handled with utmost care and efficiency. With completion scheduled for 2025, the Thames Tideway Tunnel promises to be a vital infrastructure project that will safeguard the river's health for generations to come. Who knew sewers could be so captivating? Now, let's hop across the pond to the United States, where the California High-Speed Rail Project is aiming to transform the way we traverse the Golden State. This ambitious high-speed rail line seeks to connect the bustling cities of Los Angeles and San Francisco, revolutionizing travel and reducing congestion on highways and airports. With a projected cost of a whopping $77 billion, the California High-Speed Rail Project has faced its fair share of challenges and setbacks. But fear not, for determination runs deep, and the completion date may still be shrouded in uncertainty. But the promise of a faster, greener mode of transportation is on the horizon. In the heart of Kuala Lumpur, Malaysia, a 70-acre development named Tun Razak Exchange, TRX, is poised to become an international hub for finance and business. Paying tribute to Malaysia's former Prime Minister, Tun Abdul Razak Hussein, this strategic project aims to support the country's Economic Transformation Program, ETP. With its prime location along Jalan Tun Razak, TRX embodies the spirit of progress and prosperity, beckoning investors and entrepreneurs to partake in its vibrant ecosystem. So get ready to dive into the heart of Kuala Lumpur's financial pulse. Now, let's shift our attention to sports and entertainment with the new stadium for the NFL's Buffalo Bills in Orchard Park, New York. This $1.4 billion project promises a thrilling experience for football fans, featuring an open-air design that amplifies crowd noise to deafening levels. And for those chilly upstate New York winters, fear not, because extensive radiant heating will keep fans cozy and comfortable as they cheer on their favorite team. With an eye toward completion before the 2026 season, anticipation is building, and soon the Buffalo Bills will have a state-of-the-art home to call their own. Last but certainly not least, we venture into the realm of immersive technology with the Madison Square Garden Sphere. As the largest spherical structure on Earth, this awe-inspiring venue combines cutting-edge technology with captivating experiences. From residencies by world-renowned artists to exhilarating esports tournaments, the MSG Sphere aims to be a haven for entertainment enthusiasts. The 17,500-seat auditorium was initially slated to open in 2021, but construction was halted in April 2020 due to a COVID-19 pandemic-related disruption in the project's supply chain. The opening is slated for the second half of 2023. So, my dear audience, as we conclude this whirlwind tour of awe-inspiring construction projects, remember that the global construction industry is on the rise, fueled by ambition and innovation. From the bustling streets of London to the majestic skylines of Mumbai and Jeddah, from hydroelectric dams in Ethiopia to high-speed rail lines in California, these projects represent humanity's unyielding spirit to shape the world we inhabit. In conclusion, we have embarked on a remarkable journey exploring the top 10 construction mega-projects in the world. We all know that the plank path is a remarkable invention in ancient Chinese transportation history. In order to traverse deep mountain valleys, people ingeniously carved rhombic holes into cliffs isolated by rivers, inserting stone or wooden stakes into these holes. Planks or stones were then horizontally laid, providing walkways. In this video, we'll explore how these thrilling cliffside pathways were created. First, let's talk about the plank path workers in China. They are a group of warriors who bravely construct pedestrian pathways on cliffs, using their hands and wisdom to open up paths for transportation and tourism in mountainous areas. Their working environment is extremely harsh, facing significant risks during the construction process. Yet, the outcomes of their labor are truly astonishing. They are not only miracles of China's infrastructure but also a source of pride for the Chinese people. Each plank path they build is an engineering marvel. They not only provide convenience for transportation and tourism in mountainous areas, but also add charm to the local scenery. The construction of a plank path is a challenging and arduous task. Workers not only face harsh natural conditions, but also bear enormous safety risks. Without safety protection measures, workers stand on scaffolding near cliffs during plank path construction, risking the danger of falling into the abyss. They walk on toughened glass, facing the risk of severe injury or death if the glass breaks or slips. When constructing steel pipe frameworks, the risk of pipes loosening or breaking poses a threat of piercing or injuring workers. While laying wooden planks or concrete, the possibility of boards or concrete falling could result in self-injury or harm to colleagues. Throughout the construction process, Workers must remain vigilant against natural disasters such as landslides, falling rocks, lightning, and more. Along the plank path on the cliffs, workers shuttle back and forth, seldom speaking. They concentrate on their work and the path beneath their feet. Workers are pushing mixed soil on a narrow cement plank path, slightly over 2 meters wide, a sight-inducing anxious perspiration. Due to the unique geographical location, the mountain road can only reach the parking lot at the foot, about 400 meters away from the construction site. To build the plank path, the construction team managed to provide water and electricity without conventional access to such resources. Cement and sand needed for the project were manually transported by workers in buckets suspended on ropes. However, workers on the plank path lack safety guarantees while working on cliffs hundreds of meters high. They have no safety ropes, only rudimentary tools such as wooden boards, hand carts, and rusty scaffolding. During plank path construction, finding a reasonable plank path route based on the terrain and topography is crucial. Workers stand on scaffolding near cliffs without safety protection measures, which is just the first step in road construction. Plank path workers build steel pipe frameworks and lay wooden planks or concrete, forming a stable pedestrian pathway on the cliffs. The construction of plank path requires advanced skills and rich experience, as every terrain and wind direction is different, requiring design and construction based on the actual conditions. Plank path workers usually do not use safety ropes because they would affect their flexibility and efficiency. They rely on their own balance and agility to shuttle in high altitudes. They work from 6 a.m. to 5 p.m. daily, each assigned specific tasks, earning around 300 to 400 yuan per day. The work ethic of plank path workers is admirable. They face difficulties without fear or hesitation, pursue excellence without negligence, shoulder social responsibilities without greed or selfishness. They are a group of people with noble character and lofty ideals. With their sweat and lives, they contribute to China's development and the happiness of its people. They are the plank path workers of China, and they are the heroes of China. Alright, buckle up for the next adventure. We're about to hit a road hanging off a cliff, stretching a whopping 1,200 meters. This road, believe it or not, was chiseled out by the sheer determination of 23 villagers from Zhujiaping and Lanying Village, China, over a mind-boggling 4 years and 3 months starting back in 2001. They used steel drills and hammers to carve out this marvel inch by inch. Standing on the cliff-hanging road, if you glance down, you'll see mist swirling in the canyon and towering, majestic mountains surrounding you. It's a double whammy of being awestruck by the stunning natural beauty of the Lanying Grand Canyon and being utterly impressed by the challenging and breathtaking cliff-hanging road. The road twists and turns, with a width of less than 3 meters, one side hugging a cliff, and the other side plunging into an abyss. Driving on this road demands extreme caution, or one might unintentionally take a plunge into the cliff. Let's roll! let's experience another even more thrilling cliffside road. This cliffside road is renowned as one of the world's most treacherous highways, constructed in the 1970s. With a total length of 1,500 meters, height of 5 meters, and width of 4 meters. To ensure visibility for drivers, workers carved out 30 windows of various sizes on the rock face, offering a view through which one can witness the sheer cliffs below. What is truly astonishing is that this road is hailed as the 9th wonder of the world because it was manually chiseled by 13 farmers over 5 years, without the use of any mechanical equipment. During the construction, villagers went to great lengths, breaking 4,000 hammers and consuming 12 tons of steel drills. With sheer determination and bare hands, the entire village carved out this breathtaking passage amidst the mountains. Today, this cliff-hanging road stands as a symbol of Guoliang Village and serves as the primary attraction in the 4A-rated scenic area of Mount Wanxian in China. Every year, numerous tourists flock to witness it firsthand. Are you interested in experiencing it yourself? Okay, let's go! Satisfying the electricity demands of its staggering 1.4 billion population, China has orchestrated a multifaceted approach that blends innovation, diverse energy sources, and strategic infrastructure development. This complex strategy revolves around harnessing conventional fuels, pioneering renewable options, and advancing cutting-edge technologies to power a rapidly evolving nation. In the Gobi Desert in northwest China, a group of engineers is searching for the enormous energy buried beneath the desert. A blasting engineer with 37 years of experience, along with his team, will use 1,418 tons of explosives to blow to smithereens a 38-meter thick layer of rock in an area the size of 5 football fields. At the same time, they must ensure that what goes up comes down in all the right places. The charges cannot be set off simultaneously, which would result in destructive seismic waves. Engineers choose to detonate the explosives in batches. There are 781 blasting holes divided into 12 groups. Each group will be detonated less than 1/100th of a second after the previous group. To make this work, the blasting team needs electronic detonators with an encoder. The operator must accurately control the ignition of thousands of electronic detonators in milliseconds. The Chinese have invested billions of dollars to build facilities in this arid inland area beside the desert to produce coal. The coal found here is of superior quality and has a very high heat value. It contains less sulfur and is therefore less damaging to the environment. Today, coal is still the main energy source that drives more than half of China's economy. This is one of the open-cast mines operating in China. The coal is of high quality, and the seams are very thick. Coal seams of over 15 meters in thickness are regarded as super-high seams across the world, and the seams here are up to 30 meters thick. Of course, to mine this precious coal, the upper layer of rock needs to be removed beforehand. After removing the gravel, a new coal seam reveals itself. The daily output of coal from this canyon is over 100,000 tons. It could generate enough power to supply one modern family for 10,000 years, but it's just 1% of China's daily coal output. Coal holds a primary position in China's energy structure. Because of that, it is particularly important to use coal efficiently. One of the most efficient ways is to build large power plants near the coal fields. This reduces transportation costs and keeps pollution away from populated areas, far from the cities. The west of China has substantial coal reserves, but it is very short of water, and that is a significant issue. Building a thermal power plant in a desert was impossible in the past because a traditional thermal power plant requires so much water for cooling. The boiler cannot operate without it. China has begun to construct large thermal power plants in the desert because it has found a solution. The secret lies in these passive cooling towers, which do not use water. As the hot air rises from the top of the tower, cooler air is drawn in at its base over an array of radiators. The 132 radiators are distributed in a V-shape. As this type of passive cooling tower doesn't require large quantities of water directly, it's possible to build them in the desert. The eastern part of China is home to just under 70% of the country's population and over 80% of its economy. However, most of the new energy resources are located in the west, thousands of kilometers away. Energy transportation has been a persistent problem for the country. China plans to construct more large power plants around the coal fields of western China, converting coal into electricity, and then transmitting the power through the grid to the east. This project constitutes the largest energy transmission project in human history. This power transmission line boasts the world's longest and highest voltage. It originates in the Yungar Basin in the far west of China and spans a distance of 3,324 kilometers, crossing deserts, mountains, and canyons to reach the densely populated east. This ambitious endeavor is projected to be completed in 8 years. China has built more than 30,000 kilometers of high-voltage lines to establish the world's largest energy transmission network. To increase the system's efficiency, the voltage needs to be raised. The 1.1 megavolt high-voltage line is currently the highest in the world. It can transmit the energy generated by 80,000 tons of coal over a distance of 3,000 kilometers in a day. To ensure smooth and efficient transmission, the 20,000 conductor joints must be perfectly connected. The cables are connected through intense pressure. First, the outer aluminum wires are stripped back to expose the steel core. Then, the two ends of the steel core are inserted into a metal sleeve. A hydraulic clamp presses firmly on the sleeve to hold the two sections of the steel cable together. After the steel core is joined, a larger sleeve is used to connect the outer aluminum wires. The workers need to hold the two ends of the cables carefully and avoid damaging the conductors while dealing with the 5-ton tensile drag on the cable. To manage this, they must use a special cable that combines strength and flexibility. The job not only requires concentration but also a head for heights. It will take 6 months to complete the new 3,324-kilometer line, and this is just the beginning. Historically, it has been very difficult for China to develop deep-sea oil and natural gas resources. The energy stored in the deep sea is beyond imagination. As the sea becomes turbulent, the test commences. The key requirement for accurate underwater operations is equipment stability, even in rough seas. In order to achieve this, the engineering ship must maintain a fixed geographical position against the flowing currents and heavy waves. This is achieved through the approach power compensator system. When waves push the ship off its position, the compensator system instantly activates the corresponding thruster to counteract the force of the sea. This keeps the ship steady. However, when the ship rolls or is lifted by the waves, the thrusters alone are not sufficient. But this new ship comes equipped with another special piece of equipment, the world's largest crane with an automatic height compensation system. The high-power crane is capable of lifting up to 400 tons. As the ship rises and falls with the swell, the crane automatically detects the speed and direction of the movement. It then reacts instantly by adjusting its cable lines or turning its lifting arm to compensate for the motion. To fully utilize these favorable conditions, the test must continue well into the night. Images from the underwater camera show that despite the surging waves, the 400-ton test box only moves slightly and remains well within the control range. Everyone is very pleased with the result. With the advancement of deep-sea engineering technology, humanity has taken another step in harnessing resources from the oceans. China has become the first country to successfully mine fire ice from beneath the seafloor. Fire ice, also known as combustible ice, is a common name for methane hydrate. It exists as a flammable solid in which methane is trapped in a crystal structure of water. Originally assumed to only exist in the outer reaches of space, it has been found to exist in extraordinary quantities on Earth, below the seabed. It forms the largest reserve of fossil fuel on the planet. However, extracting it is no simple matter. To date, reliable mining techniques have yet to be developed. China is making conscious efforts to increase the proportion of clean energy in its energy mix. Hydropower will play an important role in this endeavor. This is the construction site of the Wudong Hydropower Station, one of the 4 cascaded hydropower stations in the upper reaches of the Yangtze River. The excavation works have been completed to build a massive facility on the mountainside to house the giant hydraulic turbines. Engineers are planning to cast a seamless concrete dam. Concrete fracture is a recognized technical challenge, and the larger the project, the more serious the issue. There's a saying among engineers that every dam has fractures. It will take 2.91 million cubic meters of concrete to cast the Wudong Dam. The plan calls for a wall that is 275 meters high and between 12 and 51 meters thick to withstand the pressure from up to 270 meters depth of water. The dam cannot have even the slightest fracture. The key to building a seamless dam lies in the continuous control system. The casting process must continue uninterrupted for 33 months. The heat generated as the concrete sets is the primary cause of cracking. As the concrete has minimal malleability and the internal and external cooling speeds differ, this uneven thermal distribution can lead to cracks. The key to building a seamless dam is achieving precise temperature control during the continuous casting process. However, abundant water resources are not found everywhere. The west of China faces water scarcity but enjoys ample sunshine. The power of sunlight and the duration of sunlit hours make it an ideal site for solar arrays. The key components of the array are these mirrors. When the sun rises over the Gobi Desert at 7 o'clock in the morning, more than 20,000 mirrors precisely reflect the light to the top of a tower. The generated heat is absorbed by molten salt, which carries the heat down into the plant where water is heated into steam to drive turbines for electricity generation. This method of generating electricity neither consumes fuel nor releases emissions, making it an ideal way to utilize solar energy. China has developed a precise sunlight tracking system for this tower-type photothermal power plant. Controlled by a computer, the 20,000 mirrors reflect sunlight to the top of the tower when aligned accurately. The regional conditions favor solar power, but there's more than one way to convert sunlight into energy. Not far away, another solar power plant 10 times the size is under construction. It is a trough-type photothermal power plant. Unlike the tower type, this plant collects sunlight heat through curved mirrors. Both systems, however, rely on precise solar tracking. After installation is completed, the mirrors will be aligned to within less than 1 millimeter. This plant will feature 9,120 solar troughs generating 50,000 kilowatts per hour. China's currently installed solar power capacity exceeds 70 million kilowatts, accounting for 1/5 of the world's solar generation capacity. The increasing ways to utilize solar energy will revolutionize China's supply of clean energy. Its rapid development showcases China's genuine determination to transform its energy structure. However, other emission-free energy sources remain untapped. China is one of the nations taking the lead in seeking renewable energy from wind. Giant turbines have become a common sight in various landscapes. While wind energy is often harvested more reliably at sea, the harsh environment presents significant challenges for turbine installation and maintenance. Previously, turbine generators were assembled on land and then transported to their operating sites by semi-submersible vessels for final erection. This process was costly, slow, and resource-intensive. Today, offshore wind power appears to be the future of wind energy, as breakthroughs in installation technology significantly reduce costs. On the eastern coast of China, a new installation method is being trialed. This newly developed tool can accurately set the blade's angle at a height of nearly 100 meters, aligning it perfectly with the rotor hub. If the machine functions as intended, the cost of offshore wind turbine installation will be significantly reduced. The progress of science and technology drives energy development, resulting in a mixed-source energy policy. On a remote peninsula in eastern China, the world's most advanced nuclear power unit is being prepared for operation. The nuclear reaction generates immense heat, which is used to convert water into high-pressure steam, driving generators to produce electricity. The core of a nuclear power plant is the reactor unit, constructed to the world's highest safety standards. Before commencing operations, numerous and repeated safety inspections must be completed. The engineers test a 3-story high safety door made of special metals and manufactured using aerospace technologies. Like the safety door, nearly 1/3 of the plant's components are designed with the ultimate goal of safety in mind. At the business end of things lie this 10-meter deep pool and the adjacent reaction chamber. The pool will eventually be filled with pure desalinated water. The installation and replacement of fuel rods will take place here. This area has seen countless hours of meticulous preparation, ensuring everything runs seamlessly. The last round of inspections is nearing completion. The nuclear fuel, ready in the fuel bin, is securely stored at the highest level of security. Over 100 fuel units, sufficient to power the plant, are ready for use. Below this floor lies a stockpile of the most powerful energy source humanity has harnessed. Its energy density is 2.5 million times that of coal. A mechanical arm delicately handles the nuclear fuel assembly, each composed of 264 metal tubes filled with nuclear fuel. Prior to startup, they were not radioactive. For 4 hours each day, the engineers' operations are rehearsed repeatedly to ensure a flawless startup when the plant goes into full operation. Nuclear plants operate on nuclear fission, releasing energy through splitting atomic particles. While immensely powerful, this process generates hazardous radioactive waste. By contrast, the sun generates energy through nuclear fusion, producing no radioactive waste. On July 5, 2017, Chinese scientists astonished the world's scientific community by achieving a temperature of 50 million degrees, a critical milestone in fusion research. However, no known material on Earth can withstand such extreme temperatures. A magnetic field provides the answer. The coil enters a superconducting state at low temperatures, generating the Earth's strongest magnetic field. Suspended within this field are the materials for a fusion reaction. Nuclear power, though controversial, remains a great hope for an endless, reliable, and clean energy source in its various forms. Natural renewables will also play a crucial role in meeting tomorrow's demands, while ingenious solutions continue to be sought for today's challenges. In the sparsely populated deserts of the West, the search for a better future, where needs are met and waste is eliminated, persists. China is committed to this clean, green future with all its energy. The journey through China's mega projects is one of awe and inspiration, a testament to Chinese ingenuity, innovation, and the relentless pursuit of progress. Each of China's ambitious undertakings stands as a testament to human achievement, underscoring how the fusion of creativity and resolve can lead to extraordinary progress. If you found this video enlightening, please show your appreciation with a thumbs up and by sharing it with others. We eagerly await your valuable insights and feedback in the comments section below. Remember to like the video and subscribe to our channel for a continuous stream of captivating content. Thank you for being a part of our viewership, and we're excited to engage with you in our upcoming videos. Let's continue to explore, learn, and inspire together. Take care and goodbye.